Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will see what is the buoyancy and we will solve a numerical problem which is based on the buoyancy concept. Okay, so first of all, what is the buoyancy? Buoyancy is the force which is acting on a floating body in a floating or submerged body in a liquid, which is equal to the weight of the liquid displaced by this body. Okay, so suppose this is a wooden block. Okay, it is floating in the water, then what will be the force of buoyancy acting on this, okay, this block? So it will be equal to, see, this is, suppose this is height h, this is submerged up to height h, then volume of, we will calculate the volume of water up to this h height. Okay, because that much water is being displaced by this wooden block, so that weight of the water up to h height will be equal to force of buoyancy. So let's solve this numerical problem and then you will understand better. Find the volume of water displaced and position of center of buoyancy for a wooden block of width 2.5 meter. So let's note down the parameters also. So width is equal to 2.5 meter and the depth d is equal to 1.5 meter when it flows horizontally in water. Okay, then density of wooden block is 650. So d wooden block is, or we can call it rho because d is already depth here. So rho wooden block is equal to 650 kg per meter cube, and length of the block is, which is not visible in the diagram. So L is equal to 6.0 meter. Now one more thing, this thing is floating in the water. Okay, here you can see it is water, so we also know the density of water. This is rho b, this is rho water. Density of block and density of water is 1000 kg per meter cube, and you also know that g, which is acceleration due to gravity, is equal to 9.81 meter per second square. Because this is the value of g, you can always assume it. Okay, then what we have to find? Volume of water displaced. So we have to find v of water. Okay, and position of center of buoyancy. So we have to find center of buoyancy Cv. Okay, so we have to find these two values. So first of all, we will find what is the weight of the block. Okay, then if we will find the weight of the block, then the weight of block will be equal to, because it is floating in the liquid. Okay, so if it was submerged already inside the water, then weight of block would have been more than the volume of water displaced, but this is floating, so it will be equal to, weight of block will be equal to the volume which is displaced by this block. Okay, so what is the weight of block? So first we will calculate volume of block, which is cubical, not, so it will be equal to, this is not cubical because this is rectangular cross section, then it has a length, so it will be equal to this width into height into width into height into length, or you can also call it depth. Okay, so it will be equal to 2.5 into 1.5 into 6, already given in the question, so it will become 22.5 meter cube. This is the volume of the block. Then what will be the weight of the block? So mass of the block is, or you can directly say weight is equal to mg, mass into acceleration due to gravity. Now mass is equal to volume into density, and then this g. Okay, so we'll keep this value. Volume of block weight of block WB is equal to volume of block, which is 22.5 into density of block, which is given to us 650 kg per meter cube, into G is 9.81 meter per second square. So if you will calculate it, you will get weight of block is equal to 143,471 Newton. Okay, if you will multiply this, then you will get this value. Now this is already floating. It means the weight of block is equal to volume of water which is displaced. If it was completely submerged up to here, suppose water was up to here, okay, then we could consider depth of block is equal to the volume of water which is displaced up to 1.5 meter, but it is already floating here. Okay, this depth is not submerged, which is 1.5 minus h is still outside of the water. So how much water it has displaced? Okay, so how much water it has displaced? So it is only up to here. Okay, because only this portion is submerged. So we will calculate the volume of this water. Okay, so what will be the volume of water which is displaced? So suppose block is submerged up to h height, we already marked h, then volume of water displaced up to h height is equal to volume of block, sorry, weight of water is equal to weight of block. Okay, so what is the weight of block? Already calculated. What will be the weight of water? Okay, so length into width into height. So for water, volume of water is equal to 2.5, which is width, into height is h, into length is l. L is equal to 6. So it will become to 15h. Okay, so this is 15h. So 15h is volume. Now weight is equal to weight of water is equal to density of water into volume of water into G. So it will be equal to density of water is 1000 kg per meter cube into volume is 15h into G is 9.81, and this weight is equal to weight of block. So we have already calculated 143,471. Okay, so from here we can calculate h is equal to 143,471 divided by 9810 into 15, because it is 15h. So if you will calculate it from the calculator, then you will get 143,471 divided by 9810 divided by 15. So you will get 0.975 meter. Okay, what does it mean? It means that block had height of 1.5 meter, but only 0.975 meter of block is submerged in water. Okay, now what is the volume of water? Then volume of water we had calculated here 15h, so it will become 15 into h is 0.975, so it will become equal to 14.625 meter cube. So this is the volume of water which is displaced by this block. Now what is the center of buoyancy? Center of buoyancy will be equal to center of gravity of displaced liquid Okay, so if you see water is, what will be the center of buoyancy? See, if this is a block, okay, then its centroid will be at h by 2. This is 1.5 meter, then it will be at 0.75, because it is half of the height. But in this case water was only up to here. Okay, so what will be the center of buoyancy? Center of buoyancy will be not equal to center of gravity of this block, but it will be equal to center of gravity of this water which is being displaced, center of gravity of this. Okay, so it will be equal to height of this water displaced divided by 2. So what was the height of water being displaced? It was equal to h, we had calculated 0.975. so center of buoyancy will be 0.975 divided by 2. Okay, so it will become 0.4875 meter. And from where we are calculating distance? This is center of buoyancy, so we will calculate from bottom. So it is from bottom of block. Okay, so we have solved this problem. I hope you understood this problem. If you have any doubt, then you can ask in the comment section. And if you like this video, then please share and subscribe to our channel. Thank you for watching.